now we're back. Let's look at, I want to jump into exercises themselves. It's been really laggy today. Everything that I've dealt with has been laggy. And it's not the college's throughput, because I've been right at gig speed, up and down. But accessing certain servers, it's choking on this one. All right. Killing me. There we go. All right, let's talk basic housekeeping rules when it comes to programming while this is doing its thing. Syntax, or the rules to the game when it comes to defining a constant as opposed to a variable. At a glance, how do you tell one from the other?
Uppercase.
All uppercase for constants. So if you see something that's all uppercase, it's intended to not change in the execution of the code. Why would I put something as a constant and not within my code as just a static value? Why would I say constant, or call it num equals 10? Why would I do that and then refer to num in my code as opposed to just saying 10?
It makes it so that if you need to change that number at a later date, it's just easier one place.
Housekeeping.
Yeah.
One-stop shop to be able to make whatever changes effective from that one position, usually up in the header of your code, up in the top. Man, this is killing me. Rules for a variable. Uppercase, lowercase, combination thereof. What's that animal in the desert?
Camel case.
So camel case starts low. No spaces. There's one way. Another way that is also common is putting underscores within the name. Perfectly acceptable. You can have uppercases in there if you want at the beginning of those words, just like it's camel case, but you're adding a little underscore in there. That's fine. You just can't have spaces. Testing my patience now. All right. Can I have a number at the beginning of a variable name? Got to be a letter. Can I have a symbol? Don't do it. Tell you what. Testing the effectiveness of my medication now. Come on. Woo! All right. You can do these many times as you want. Take all the time you want to do them. They don't lock. Basic problem. I mean, it is really a basic problem. And in this problem, we import math. I don't call it anything other than math because the name's so damn short. I do reference it explicitly though, because there are other libraries that have a value for pi, a calculation or a value for pi. So pi is this long number. And in this, I think they say something, no, they don't say anything in this one about it, but there's a specific number or length of precision. That's what we call how far you go out from the decimal point, is the precision of that value. We'll deal with in these specific formatting on precision, but not in this one. So in line 3, what did we do? Import a library. Somebody wrote code. I'm going to use their code to acquire that value for pi. And when I want to use it, I just mentioned math.pi. Go into that math library, get me pi. I declare a variable called radius. Here's my input statement. It's a built-in function in Python that is input. Straightforward, simple. Bring it in, typecast it to a float. What are you seeing?
I just think it's so much better than C#.
It's cleaner.
Yeah.
It's cleaner, but it's cleaner because it is so much lighter. Now, one of the things we don't have here in this exercise, we're not dealing with a main method. Well, I've got it in another one. We'll deal with object-oriented in like number 8 or 9 or something like that. So this first module covers a lot of ground when it comes to, let's say, intro to programming. There's a lot of ground covered. So with that, input, it's built into Python. It returns what data type? Every language is the same damn thing. An input statement acquires what from the user? Keystrokes, which equate to a string. They're captured in by default as a string. So we're bringing in individual keystrokes. We treat it as a string. If we want to do anything other than treat it as a string, we got to typecast it. Easiest place, best place to typecast it is as soon as you bring it in. Unless there are times that you'll bring it in, give it a variable name as, you can call it radius in str. And that's just telling you that, oh, here's what was brought in the data type of string. Then typecast it. Takes up more memory.
Does it sanitize it as it's coming in? Like, if somebody puts in something that's not a float, if somebody starts putting...
No, you'd have to do a try-catch to clean that up.
Okay.
So if it's, that's on the logic side of it that we haven't even gotten to on this. And is something that you should have had before. I've got it in those other notebooks. How to deal, and it's not even called try-catch in Python. Try, but it's not a catch. So there's little nuances like that, and from one language to the next, they're not all the same. I had students that have taken C# and at the same time they're taking Java. It's heart-wrenching to watch, because they get used to one syntax, or you get used to C++, and then you go into C#. It's like they're not all the same. There's a lot of similarity, but now we got no termination at the end of the statement. That's still implicit. Not to say it won't ever be. Right? So we typecast it, and if you think about it, by doing it this way, we only saved one place in memory. Does that make sense? We brought it in and typecasted it before we stored it. So it was in RAM before it ever got into any kind of potentially long-term, and it's not all in RAM anyway. But it didn't get stored for reuse until it had already been typecast. We come down, I got the calculations, try to keep the calculations all in one logical grouping, at least for what we're dealing with. I may have points on tasks that are directly related to comments and white space. So if I put in there, there's 5 points here for comments and white space, know that if you're not effectively using comments and white space in there, then the points ain't coming. So it's when I say these are clear objectives, there should be no confusion about it. I should put up here a comment. Here's my imports, here's my housekeeping. If I was going to declare variables, where would I declare variables? After the imports, I would do it here or I would do it here. I treat it the same way as inputs, and here's why I say I treat it the same way as inputs. If we're thinking algorithmic, there's 3 things that take place in an algorithm. The first is we got inputs, something coming into what we're going to do. The second is what we do with what we've got to create the output. And the output's the third. So there's input and output, and what we do in the middle, that's our compute, or the work, if you will. So on inputs, to get to this point, could be up ahead, which traditionally we'll do a lot of it up there, define the constants, define the variables. Then come down, get the things from the user. Works. A lot of these I've got it to where, let's do the inputs. Get the stuff from the user, here's everything else you need, now go do it. As long as you've got those logical groupings, I need to find out what data type it is. Well, there's a section up there, there's where it's all taking place. There's something that takes place in these exercises, and one of the videos you'll see it. Shows you an example of it in one of the notebooks. If I said diameter equals 0 up here, what's taking place in that statement? Diameter equals 0. I mean, well, let's break it down into what's taking place in those 3 little things. Diameter equals 0. Did diameter exist before that? No. So I reserved or allocated some memory for this thing that I'm calling diameter. It's almost like I rented a storage unit. Did I know what was going in it? In Python, it's implicit still. I don't. Unless I go about it a certain way and see in those Python refresh notebooks, there's certain things like the square braces. That's a list. That's a list. So if you're passing something in square braces to a variable name, it knows just by seeing those square braces. I know what that is. But it's not an implicit language like you may see other languages to where you declare it and you actually tell it this is an integer, or this is a double, or this is a float, whatever it may be. We don't. So we declare it, and when we declare the variable, we reserve the space. We're pointing to that space in memory. kind of mapped to it in a way. It's not a pointer, it's different, and we don't have pointers in Python. But just think about it as, this is how you get to my storage locker. I got a locker, here's how you get to it. Anytime anybody references radius, that locker over there, that's where you go get it. By giving a value, I initialized it. Not only did I rent that storage locker, I put something in it. What if I said, right here, diameter plus equals 2 times radius? I don't have anything up top right now. I just said diameter equals, plus equals 2 times radius. What's plus equals mean?
Increment by 1.
I'm adding whatever that is to whatever's there. So I'm saying, hey, take what's in diameter and add this to it and store that in diameter. Now, if I said plus equals 1, then I would increment it by 1. I'm saying take whatever's in diameter plus equals 1, take a diameter and add 1 to it. That would be that single incrementer. With this, I don't have to, I'm not limited to just 1. Increase it by whatever's there. If I did not initialize it, say I didn't initialize it at all, I just said diameter plus equals 2 times radius. Take diameter and add this to it. For it to do the work, it's got to go over and look in my storage bin for what's in diameter to be able to add that to what's on the right side. And it's like, you got nothing. So there's times, and you'll see it and like I said, in one of the videos, one of the future exercises, might be 6 or so, that if you don't declare and initialize before you perform a task with that variable, it's gonna, add something to air? I got nothing, I don't even have air. I got nothing in there, it's just an empty locker. So we've gotta be logical about how we go and step by step. And know that depending on what we wanna do with these variables, we may, certain operations, we may have to have something in there before we can perform certain tasks. So that level of familiarity we have to have. For this, that's cut and dry. I didn't have to have anything in diameter. We did the same thing that we just talked about. We took diameter, we assigned a value to it. That's an assignment operator. That's the equal symbol is an assignment operator. Other operators later. 2 times radius, it does the math, computes it, drops that in there. More the same thing, with the difference, when it hits that math.py, how I call it, I got a guy. Math. All I gotta do is call him, that's my phone a friend, and he will give me the value of pi. And that's exactly what takes place there. The fact that I've got a connection to math, anytime I invoke math, I've got all that functionality associated with it. It's got, I remember we used to call it IntelliSense. I don't know if they even got a name for it in this platform. But we've got it here. You go math dot, and it may give you a drop-down list. Hey, what are you looking for? And then, like I said, we've called it IntelliSense for years. When we have declared a variable, once I've already used some name. If I want to start typing, like when I start typing here, as soon as I hit D, I get a drop down. You want to use any of this? No, I'm making something new. All I have to do is mouse over, click, boom. I don't have to type the rest of it. So it's a little more efficient there. Those calculations should be all straightforward. We use that math library, 3 times. One of the things that takes place down in lines 15, 16, 17, and 18. I'm invoking or calling that print function. And that print function, I am passing 2 values separated by a comma. When I pass 2 values like that, the print function itself will insert a space in between those 2 values. Does it on its own. Whether you want it there or not, it will put a space in between them in the output. Now, the way this is laid out with the space between R and the colon, that's just to pretty it up so it comes up in a straight, nice column. So when I run this, say radius, and what did they use? 4. We've got a vertical line, colon over colon over colon over colon. We'll deal with that in another exercise, same concept, but instead of doing it that way, we'll get into formatting the strings and prettying it up a little bit and saying, here, we're going to formally have certain spaces. We good with this so far? Anything new?
Volume doesn't match.
Or 2.
Needs to be 4/3.
Yeah, I did change that, didn't I? There we go. Sweet. It wouldn't, if I didn't have it right, it wouldn't have evaluated it, but I went through and made changes after the fact to say what's what with the different things to show. In the video that I recorded, I talk about debugging MindTap, because it can be a pain in the butt to debug. Y'all dealt with those, had C# with it, you dealt with it. All right. Close that one. This one. I'll add in, so in the module, I've got that page for algorithms. Don't dig deep into that. Aside from that first slide that I've got in there that says, here's how an algorithm's broken down. Input, the processing, and the output. Look at the couple after that, but don't dig deep into it. Not yet. So with this one, should be pretty straightforward right here. Get 3 inputs. They're all 3 typecasted. Camel case. We come down to the next part. There's the computation. Fairly straightforward. How cheating is this? You think about how ugly MindTap was when it came to currency and formatting C#. remember globalization?
Lost hours for that.
Pain in the ass, isn't it? It's an added on little blue box.
Yeah.
Why'd they do it? Why did they add globalization in there?
Because of the
No worries. I had nothing initially. I'm like, why would they do that? And then I dug into it. I'm like, oh, well, that's cool. Depending on what language you're dealing with, what country you're in, you want to do yen, it checks to see what you've got it set at, and it would have it in yen as that symbol. British pounds, euros, whatever it may be, it has that monetary symbol, is the best way to word it. This is the easy peasy way to do it, but what's that plus symbol do? It's a $15 C word. Concatenation. Yeah. What's it mean?
The combined.
Two train cars coupled together. So we have, what do you call the green? String literal constant. It doesn't change. It's literally gonna be printed and everything will happen to it exactly the way you see it in between those quotation marks. It's a constant, but it's not something we declared up top. It's coupled together with what you see here. We used the round function. We don't have to have math for that. That's built into the numbers classes. Total pay, what's the 2? We're rounding 2.
Non-decimals.
Precision point. Yeah. So it's a nice little function. If I want to make this pretty at the 2 decimal points, round, pass it the value, put 2. I can say round, pass it the value 3, but, so here's one of the things, and I talk about it in the video when I'm running it. I set it to round to 2. But all the numbers that it looks for end up with 0.0. But it doesn't display 0.00. Why? Why would it not display 0.00? There's nothing to display. If there was another number beyond 0, 0.15, okay, we're good. You will see both those numbers. But if there's nothing but 0, it'll only put that one value there. If you tweak this and passed it a fractional number in the calculation, it'll stretch it on out. But everything they do, 0.0, 0.0, and I'm scratching my head thinking, this is a hell of an example. Go round it to a precision point of 2, but not test it to display to the 2 precision point. All right, we good with this one? This one would have been a little complicated to understand what they were looking for because of how it was worded. Essentially, they want you to find out the bounciness of some ball. So you're going to drop a ball from a specific distance from the ground and calculate the bounciness. And the bounciness pretty much equates to how many times it bounces and how far up does it come each time. I think back when I was a kid, what do they call them, super balls or something? I'd hold it here and drop it, and it damn near hit the roof. They were that bouncy. So this thing calculates the bounciness. no worries here what's taking place, right? Why did I do this? Right there. So now, before we ever hit it, now you know, that's what he was talking about. If I did not declare distance right there, and to prove my point, how do you do comments? Nope. Wrong one. Hashtag, pound symbol, number symbol. Damn, they just come up with so much. All right, so it's running. I commented that out. It's running. So far, so good. The height from which the ball gets dropped, 10 feet. The bounciness of the ball, 0.6. The number of times the ball bounces, 20. There it is. Once it got down, so it said, I'll let you through here, no worries. I'll let you through here, no worries. No worries, no worries. We got a problem. And it wasn't until I got into that for loop that we had a problem. I pull that out. And three, 1, 3 is the numbers they do. Do it again. 3, 1, 3. It calculated it. Total distance traveled, 18. Somehow we can go through and calculate the bounciness. But this is one of those things, you had to declare it before you could do that task with it. Now, I want to talk about this loop aspect. And that loop aspect where is it I want to be? Here. How many times do I go through this loop? As the structure as we see it. That's a logical structure. It's a repetitious structure. How many times, and we run this program every time is, in theory, different. So this time, yeah, we ran it 3. But when we analyze this loop, how many times did we go through that? Bounces times. Or we don't know what bounces is, so traditionally we'll say n times. So with that said, we know we're going to go through it n times. We're going to start. We're going to go. How many times do I do this? And it's technically, it's n plus 1 that I go through this. I don't do it n, I do it n plus 1. This I do n, this I do n, and this I do n. But this one, why is it that I do n plus 1 and not n? Let's think about this. Well, let's say it's 3, like you said. It's 3. We start out at the first one. We do it. Bounces has a value of 3. So we're going to do it as long as we're in bounces. Start out at the first one. We did distance once. We did height once. We did distance once. We back up to the top, we do it a second time, right? We check to see, are we at the end of bounces? Are we still in bounces? We do this twice, twice, twice. We come back up. We do that test again, a third time. And we do this test to see, are we at the end of bounces? No. We're 3, we're still in there. We do this a third time. We do this a third time. We do this a third time. We okay with that logic? So we've done each thing 3 times. I get to the end and I'm still indented. I'm still in this loop, right? Have I quit yet?
No, it has to.
I don't know to quit yet. I've got to come back up and do that test one more time to know I'm done. So that first header, we'll call that the header to the loop. We do that n plus 1. N is, if we're dealing with a list or an array, the length plus 1. If it's a value, a float, or and we'll say, we prefer an integer because we don't want to go through iterations of fractionals. Say it's an integer, whatever that integer is, plus 1. I can't have a string or a dictionary that I'm looping through, but the range is going to get me through certain things. And I guess I can go through a string, and we'll treat the string as indexes, 1 for each character. It has length. Dictionary has length. So if it has a value of length, it'll get me through these things. So the header, I do the length plus 1. The things inside, I do n. So this is n plus 1, this is n. Okay with the logic behind that? All right. That's huge. It's really huge. Because if we think about time complexity, now you know how this thing's working. And if we're going to use these structures, these repetitious structures, we got to know how much work's involved in this thing. If I'm doing nested loops, all right, this one's n. Oh hell, now we're down into n squared. Now we're down into n cubed. Now it gets really ugly in the time complexity. We'll deal with that. But it's one of those things that it's easier to get a heads up about it now, because you've dealt with loops. You just never thought about it from the standpoint of how much work's going on there. I just wanted, before up to now, I just want to get through this, make sure it's not, what's the one word that we don't like to think about when we're thinking about loops? Infinite. Can you have an infinite loop in a for loop? Not really. While loop, easy to have an infinite loop. Because we need some way to get out, and if we don't build that mechanism in to be able to get out, realistically, that's infinite. And there'll be some structures, we've got to deal with structures that are like that, or a structure that's an infinite loop, we've got a name for it. We'll deal with that when it comes to algorithms. There's some structures that I could almost equate that project that I was telling you guys about, that hours watching this damn thing run. And I hope my connection doesn't die. I really hope my connection doesn't die. Because all this time, and you can't just pick up where you left off. You gotta go start the whole damn thing over. Man, another 14 hours. There are things that take so long that when we're looking at the time complexity, That ain't infinite, but it might as well be. This thing's just obscenely long, and there's gotta be a better way of doing this. So that's the kind of things that we'll look at when we're looking at the time complexity. There's measures that we can look at. This one's not bad. If I had this at, for each pass in range 20, for each range in range 20, that's constant time. Every time we run that loop, it's the same. It doesn't matter. It's all the same. It takes the same amount of time. But when we pass it n, that's when it gets squirrely, because that n could be 4 billion, could be 1 million, could be 2. And knowing, all right, that's a big number. How bad is it? Whether it's 2 or 20 million, I understand the logic behind what's taking place, and I can go measure that. What if I pass that 20 million? I can go literally do the math. I know how fast that processor can work, and I go do the math on it. Not something we're gonna do, or even really talk or think about doing, but just have the understanding that if I can measure something, I can control it. Don't forget that. If you can measure something, you have the ability to control it. You may not have total control, but you at least have the potential to control whatever it is that you're measuring. Think about your debit card. If you never measured what was going on in your bank account, and by measuring, going and looking at your bank account, that is measuring. So if you never looked at it, eventually what's going to happen? Bam! Today's the day. Sorry, Mom. Can you pick this check up? You just never know. The way to avoid bad things happening, we measure, we monitor, and we have an idea what's taking place. And that's the whole logic behind that. We look at it, when I pull this up, you weren't even thinking about the fact that we start talking about time complexity associated with that. But with what we're gonna deal with further down the way, it'll start to make sense. So this one, when I said this one's pretty straightforward, it's pretty straightforward, right? Aside from now knowing, hey, there's certain things we gotta do before we can do other things. And it is a clean language, it really is. I get frustrated sometimes because there's things I'd like to do that are non-native. They're not built into it. I've got to go pull in a library. But once you start understanding and getting exposed to the different libraries, wow, this is cool. There's a whole lot that somebody's built programs for that it'll do for me. Now, this one, probably one of the ugliest ones out of the whole damn section. If you didn't know who Gottfried Leibniz was, you wouldn't even know what was expected of you. You'd have had to Google it. They didn't tell you. So they built it into where they gave you a file. Here's the file. I don't need this file tree. I don't even know why they've got it up there. I can't even pull it out. It is fairly straightforward. It's just a calculation. Input 3 variables, pi over 4. They didn't do camel case, so it just looks wonky. You run down through it, and it comes up with, I think it's estimating what pi is based on how many times you go through it. Don't even need to waste time looking at it. All right. There's aspects of this one that throw people. They give you a header up top. Here's the constants that you need to declare. Annual interest rate equals 12%. If you have to go declare it, and they weren't explicit about how you write that out, they just said, come up with annual interest rate and assign it a value of 12%. Well, annual rate, it's constant. Got the underscore in there to separate the words so that at a glance it makes sense, as opposed to pi over 4. This is easier to look at, isn't it? So when you go about defining things, you'll get comfortable with it. You can get lazy if you want, but you end up paying the price down the road when you, what was that? I don't know. It happens. Constant, we know it's a constant because all uppercase. Is that an uppercase or lowercase underscore? Programming jokes. I had somebody, just can't make this up. I submitted a paper and I think I was working on my MBA. And the guy that graded it, I mean, it looked like somebody bled over this paper. He graded it in red ink, and it was just horrible. And it had to be APA format, but I didn't know APA format. I didn't know before then that you could italicize a space. He knew. You didn't italicize this, or you didn't italicize. Come on. Are you grading my content? Or are you like the APA guy? He was the APA guy. It was brutal. Formatting is a big deal in this language, though. It really is. Any programming language, formatting matters. Spacing matters. Indentation matters. Just like most other languages, if you're going to create a loop, the header in the loop has a terminator. What is it? Header for a for loop, header for a while loop, header for a conditional has a terminator to identify it as a structure and not a statement.
Colon.
It's colon. We don't have semicolon, but we do have a colon. Testing your memory there. Because we just saw it, but it's one of those, damn, I don't remember it. There it is. Here's a while loop. While balance is greater than 0, colon. You insert the colon, you hit enter, it'll automatically bring you down to the next line indented exactly where you need to be. When they started doing that, I'm like, it's about time. I didn't even see it till then. So with this, what do we have going on in here? We've got a while loop. With a while loop, we traditionally don't know how long we're going to run through these things. While loops are notoriously n. They're not constant. Balance will change from one to the next. So this is going to be n. If it said while true, oh yeah, that's going to be n. Because whatever it takes to get out, that could change from one time to the next. So it's not constant. We get down in here, and now we've got conditionals. Python has something called elif. It's like elf with an I in it. Elif. And essentially what it means is else with an if right underneath it, but we do it all in one line. And I don't have it, we'll deal with it, you'll see it at some point, you can see it in those notebooks that I'll post if you go in there. But it allows us to have multiple conditions. It's like having nested conditions. You'll have the high level, and then as you come down, elif, else. Bam. Elif, else. Switch statement or case statement is essentially what it is. That we don't have a switch or a case in Python, but elif structurally allows us to create that kind of thing. This isn't elif, but this is if, colon, else, colon. Nothing beyond that. Now, this is indented. What's that mean when we see this indented? Is it part of the if else? What is it? What's it part of? Still in the while. So we came down to here for the while. Anything in there, that's a while. So that level of indentation for if, else, principal, remaining, print. Hell, we're still going. Balance, month, all of them still in there. Now, this one, I like that they did this. What are the numbers that we need? Enter the purchase price. Don't tell me what it is, but go ahead and run it. Enter the purchase price. Come on now. Ugly. It stretched it out. You had something like this in C#. It was real ugly to space it out. One of the things this does is gives you some insight into how to build those columns structurally. Talk about it in the video, but we'll talk about it here for a second. Got to hide this to be able to see it. See how much of this we can hide. That's about all I got. All right. So where it says display result, here's that header for the output. Prints one time. We won't see it any more than one time. It's spaced out with some spacing in between. I don't know how many spaces there are, but I could go through there and arrow through one by one to see how many. I can count them. So in theory, I could count how many spaces it is from M to just before the S. And then I can do the same thing from S to just before the I. I can go through and count that spacing out. If I know that number, I can come down here and format my stuff out. Point 2F is 2 precision points. The 15s are how many characters are in that output. 15 column width, let's say it that way. 15 column width, so whatever you put in there has to be less than the 15. And the balance is how far it is between the end of that and the next column. Does it make sense? So it's play with it. I'll set up a notebook and you can go in and play with those kind of things and see, here, if I do this, what happens? You can go grab this code and drop it in there. And just, hell, once you've got scores for this, and it pushed the numbers over, go play with it. Change the numbers and see what's it doing. When I say it's n time complexity, n is that input, right? The bigger that number, the longer this damn table. So don't give it a big number, kind of keep the number small. But the sad part is, they're doing it by month. I don't know if they've got it set up at a certain number of months. I'd have to go back and read it again. But try to keep things small. And that way, it makes it easier to chase through it when you're playing with it and not, man, I got a whole lot to deal with there. All right. Okay, mas. Can't believe it's after 9 o'clock already. You see the clock? All right. All right. So in C#, you dealt with pulling stuff in from a flat file. I call them flat files. It's just text files. We're not dealing with two-dimensional structures. It's usually just a text file, CSV, something like that. They give you a data.md. We'll not even dwell on what a .md file is. Just say, yeah, that's the same as a .txt. It's just a data. That file has a structure, 3 values per line. If you're going to deal with any files, when you're going to read data in from any file, database, whatever it may be, you have to go take the time to look to see what it is you're dealing with before you ever write the code. What kind of file am I going to be reading in? Why do I need to know? Because if I don't know what's in there, I won't know how to pull it in and where to store it. I need to know. Yeah, Python will do things implicitly. If all I'm going to do is read it in and print it, okay, non-issue. I'll bring it in, whatever it is, I'll typecast to a string and make sure it came in as a string. I don't know. Is it going to come in as a string in a stream reader? And it's not a stream reader in Python. Logically, it's way similar to C#, but not 100%. Take the inputs. We're getting a string from the user. Tell me the name of the file you want me to connect to. It could be, let me back up. In this instance, it's a local file, so I don't need a path. As long as it's local, I just need the name. Were it not local, I need a path to get to it. So since it's local, all I need is the name. We stored a variable called file name. It's a string. We then take that string and pass it to an open function. C#, you had to go bring in special classes or libraries to be able to do what you had to do. You don't have to on this. It's there. We just open a connection to that. It's local, open it. So at this point, we open the connection to this file name, whatever they gave us. What type of connection is it? Read only. So I can read whatever's there, I just can't touch it. I can parse it. I'll read it in theory, line by line. But for this, I open it, this is the connection. So in C#, I would have used 4 letters CONN to know, hey, that's a connection, a file connection. With this one, well, we just said, it's our input file. That's where we're getting whatever from. Header, similar to what we already did, but we passed it, and think about this, instead of printing out this long line of characters like we did in the last one, what did we do here? In string formatting, we said, print this string. That percent symbol, in essence, what it means is the first part here, from percent to the S, is name. Percent to the S, hours. Percent to the S, total pay. So it's like putting little placeholders. Hey, create space this wide, or in this format. In this one, it's just this wide, and put whatever's in parentheses following the percent. So we're saying, hey, go get what's in the first position, make this much space for it, and put that there. Go get what's in the next position, that much space, and put that there. That's all it does. So there's 2 ways to do the same thing. Creating columns. That's all we're doing. So we created those 3 columns. One's 15 across, one's 6 across, one's 15 across. And now we've got this for loop. That for loop. Is it C for constant, or is it N? It's not nested loop, so it's not exponential. Or non-polynomial. It's N because I don't know how many lines are in that damn file. It could have 1,000,000 lines in the file, or it could have 1. It depends on the file that we're reading in. So we don't know, it's N. For each line in that input file, we're going to take the line and we're going to split it. So we go get, let's pop over to that file again, we get the first line. How does it know it's done reading the first line?
It reaches a new line here.
Reaches that new line, the escape sequence or character at the end that tells it come down. We don't see it. It's implicit, but it's there. It wouldn't come down to the next line without it. It reads that line in, and it splits by default by the space. It splits by default by the space. Now, if it wasn't by the space, I could pass it a value and say split by comma, split by what, semicolon, split by whatever character we used to divvy up what's in that line. But by default, it's just that. Just a space. Or what they call non-breaking space, people would call it in HTML. So we read that line in, split it apart, and store it in a list. All right, so I got a list. Lists are not necessarily vertical or horizontal. We visualize them mentally, and a lot of times when we display them, we visualize them vertically. So we look at it vertically. Here's a list, like a shopping list. Index 0, index 1, index 2. There's only 3 items in there, 0, 1, and 2. Those 3 items, we take the name, that's that list, index 0. The next thing that we read that got dumped into the list, so we hit the space, index 1. hit a space, index 2. That's what took place in there. Now, once we've gotten here, we took that list, we took the values that were in the list that we read in, and we dumped them into individual variables. Name, hours, pay rate. And we typecasted 2 of them based on the information we got when we went and looked at the file to know, oh, those are integers. Oh, those are floats. So since I know what they are, what is it right here? It's a string. Once we passed it to float, it's a float. It's stored in pay rate as a float now. So we acquired these values from that flat file, put them in variables, or typecasted 2 out of the 3, put them in variables, and then we came up with a calculation. Wait a minute. Does this line look like that line? It should. What's the difference between those 2 lines? The fact that I've got this one as decimal, so we've got that part, and I'm not passing it string literal constants, I'm passing it the variable values. But beyond that, the lengths of the things that we have, those are identical. The only difference beyond that is that 0.2, setting the float to 2 decimal places. If I didn't do that, it'd be whatever it wanted to do. So if I create the header this way, I can copy it, paste it down in the loop, tweak it to insert the variables instead of the static header names, and maybe a little bit of formatting if I need it. And then the rest of it, every time you go through each of the n iterations, it doesn't matter if that thing had 3 items in the file or 3 million items in the file. It's gonna stack that chart exactly how you want it.
So this loop is iterating, it knows to just go through every single line just by calling the name of the file input file.
Not quite. Not quite. So, just like he said, how does it identify the end of the line? There's one more tag in there you don't see. It's the EOF. And that's when it comes down in the file, and there is no new line. There's nothing down below. So when it's reading in, it's going to read until there's nothing left to read, and it recognizes that, or there's an actual tag in there that's EOF, and it's going to say, look, we reached the end. We got nothing left to read. Same logic as what we talked about before. So on this one, it'll read, it'll read, it'll read, it'll read. So the first one, we say it's n complexity, but it reads that header n+1. It reads something, first one, reads the second one, reads the third one. It tries to read, but it's got nothing. So it did that 4th iteration, so there's that n+1. But when it comes to the whole thing, we still call it n time complexity. It's not constant, there's no constant to it because we don't know from one file to the next. But everything that was in that loop, when we look in it, how many times did we do this? N, 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 n+1. Does that make sense? Because you've got to have that extra time to realize, oh, we're done? Oh, we're done? It doesn't see, it's not like we're running a marathon and it sees the finish line up ahead. Here it comes, all right. And it knows it's done just as it's hitting it. It's not like that. It's going through, it'd be like you've taken, I hate when people do this, but they'll give the exams that you only get one question at a time. And if they didn't have that little thing over the side telling you how many questions you got or which question you're on, oh, well done. That's it. That's it. Oh, I am done. But you had to click one more time to realize, oh, I am done now. So that's the logic behind that. And that's, like I said, that's huge. It's something that you've dealt with over and over and over again. Repetitious loops, or repetitious structures. You've dealt with those in the past, in more than one class. And now we'll deal with them in a way that we look at the time complexity, and then we start maybe doing some math to figure out, man, what's the worst case scenario? What's the best case scenario on this? If I'm doing searches or sorts, there's a best case scenario, there's a worst case scenario. And if I'm going to sort out, let's say I have an array. I asked you to enter in 20 numbers. So you're the user, enter in 20 numbers, and I store them in an array. I can't assume you entered them in order, ascending or descending, any order. You just entered in numbers. If I want to search them, there's algorithms that exist for search. But for the algorithms to work, I need it sorted out first. And what's the best way to sort them out? Well, there's a bubble sort. We can go to the end of that array and say, all right, here I'm looking at the last number. Is it smaller than this one? Yeah, let's swap them. Smaller? Swap them. And we go all the way through. And then we go back, and now we're one away from the end. Are we? No, we're right back to the end again. Got to go do it again. We got to go do it again. Every time that we go through that entire sequence, there's something that we can do, there's something we can say, and we call it the loop invariant. And the loop invariant in this example is that for I, and I is the number we're going to go back to. So when I start my first time through, I'm going to sort all the way over to an index of 0. So for whatever I is, when you get done, you have I plus 1 things sorted. If I is 3 and you're done with it, how many things do you have done? You got 3 things sorted. The index is 2, but you've got 3 things sorted. It doesn't matter at what point in this, and you're going back through this thing until you've worked your way all the way across it, but at any given point within that structure, whatever I is, as you're going through it, you know from that point all the way to the left, that's all sorted. It's a given. That'll help us know that that algorithm that we're using is reliable. Every time we do this, that statement is true. It's a big deal. It's a big deal. Let me see how much we got left. We got 6. I'm glad I showed this one instead of just saying, you know what, let's call it quits for tonight. This is the beauty of libraries. So in this, I said, what they wanted you to do as the authors, creators of MindTap, they wanted you to go create 3 functions. I define the function def, give it a name, and then whatever arguments are being passed to it. Arguments, parameters, swap them back and forth. But whatever I'm passing to that, from whence I called it. So I have this list that somebody gave me, a list of numbers. The user inputted it, or it was predefined, it doesn't matter. And we pass that list of numbers to the function. And I pass it to all 3 functions, pass it to it. That list is passed in, and then I say, you know what? This function returns a value to whence it was called or invoked. So wherever you called or invoked that mode function, we're going to pass it back. Whatever we're returning, return some value. And it's returning the results of, I know a guy. His name's Statistics. And he's got a whole slew of mathematical functions built in. I liken it to when I talk in COP 1000 or C#, all of them, I outsource work. I don't want to have to do it. I got a function that'll do it for me. I know a guy, named Statistics, and he's got a mode function. I don't need to know how he does it. He just does it. I give him the list, and he gives me back that value, the mode. I give him the median when I use that median function. Boom. He's got a mean function. I could do that too. I went and wrote that one out the way they wanted it written out. Formally, you doing the math. This ain't a math class. Even though we'll deal with math when it comes to the algorithms, but we'll focus the math on where we gotta focus it on. Not, you need to know how to calculate the mode. And you need to know how to calculate the median. And you need to know how to... That's a math class. That's statistics class. That's not this. I got a statistics guy. He's in the library. And he's got those functions. So when you know those libraries, invoke them, import them, bring them in. You could say, import statistics as stats. You can give it whatever alias you want, as long as it wasn't something reserved already or something somebody else was using. You don't have to use the whole word, used it. Let's see if I have to use it. And when I say go play with these things, this is the kind of things I want you to do to go play. See what works, what doesn't work. And we run this. Enter the values for the list. 41, 42, 45, 46 are the numbers that they used. It had a problem. It had a problem. And it's not really telling me what the problem was per se, but we see it right there. It's saying return mode, and it choked right in there. So if I came back here, Control Z, 41, 42, 43, 44, no problem. So when it comes to those two terms, explicit and implicit, are we good on the difference between those? If I bring something in, I either call it exactly what it is and point to where that library and that function's coming from, or I give it an alias and I'm explicit about it, but don't be implicit the way I just was. Try to avoid that whenever possible, because it will come up and bite you right in the rump when you're not expecting it. Whether it's something like that, where it's like, there may be a mode function somewhere in Python that didn't work the way I wanted it to work. And it started spinning its wheels and was like, I don't know what you're doing. If I'm gonna use something, I gotta be real clear about what I'm using and how I'm using it. It works when we go by it. Did I have to go through? I'd just love to show you. I got the code for it. What they wanted in there. Oh, hell no. I'm not gonna make you guys do that. That's ridiculous. We're not in the stats class. It's not even a high level algorithms class. This part, there's tools out there. Does everybody know what the mode, median, and mean are? Anybody not know? If you don't know, throw it up, because that's something that you do need to know. It's not complex. I mean, there's things that we just may not have covered at some point. Right? So what's the mode?
Most common.
Most common, you see it the most. What's the modulus?
Remainder.
Had nothing to do with what we were dealing with in there. All right, here's one. 2 \1. Oh, no, let me come up with another one. No. Oh, I'll show you. No, I can't show you in this. Do I have a notebook up still? I do. There we go. Give me a number that's going to be fractional. 25 divided by 3. You okay with what's taking place there? Come on, I thought I already did this. Oh, that's dirty. Well, let me in straight away. 25 divided by 3. Simple math, right? I run it. Run anyway. I know who wrote it. It's going through, connecting to the server, borrowing some time. Is that right? What determined the precision point? The software did. I didn't go in and say round this, comma 2. Now, I could, right? It works. Playing with this stuff's a good thing, isn't it? Now, what if, I'm not going to do that. What if I did that? It's right there. And you're right. That's exactly what it is. No, seriously, it's one of those things, you've seen it, you know it, but it's like, ooh.
Is it the floor symbol?
Mm-hmm. What did it do?
Give you the whole number.
Whole number only. Let all those fractionals, it's not rounding, it's letting everything go. You may need that. Why would you need that? I can't deal with floats in what I'm doing. I need whole numbers for what I'm doing. We can't have, how old are you? Here's a calculation. 13.6. What? What would happen if you asked somebody, how old are you? I'm 32.987. Get me? Let's go ahead and we'll just lop that off and just say 32, because you haven't turned 33 yet, have you? No, and that's all that is. We're not rounding and say, well, you're almost 33, so we'll just call you 33. No, you're not 33 yet. That's the kinds of times when this comes into play. So there's operators that we have that are new. I've got those and those notebooks as well. I'll add the page tomorrow morning. There's so many errands I gotta run tomorrow morning, but I'll do that before I go run them. So I'll add the pages in. I've gotta add the videos into the pages first. At least the first 5 pages. The videos already exist. I've just gotta go in and add in the lecture videos that go along with those modules to walk through the concepts. So it's just like being in the COP 1000 without having the book, and I actually, in some of the modules, walk through chapters in the book and the video. Good refresh. And if you didn't have Python, it's huge. Don't jump into, if you're killing time on the weekend. Had a guy, we were joking earlier in a class, the guy asked me, he says, hey, can I just blow through everything in the class? Since it's all available, can I just, at my own time, blow through it? The only thing you can't do is discussions, because you can't have a discussion with just yourself. It'd make me nervous if you get in there and you actually find a way to do that. But I said, I had a guy that he went through 2 of my classes before the trial period on Cengage expired. One of them was the A+ class before I split it into hardware in 1150 and software in 1110. It was hardware and software in the class that he took, all in one, 18 chapters in 2 weeks. And I'm like, dude, what? He says, I've got no wife. Look at him. I mean, come on. He says, no. And he had mobility issues. Hell of a guy. I'm one hell of a guy. So smart, but it's hard for him. He wasn't as easy to move around as most people are. And he says, it's just easier for me to stay home and do my thing, and I do a lot of gaming, and he says, I'm damn good at it. He says, so I might as well do this. Wow. Wow. Knocked out all. You guys won't have that luxury to be able to knock out stuff because Module 2 ain't open until next week. So we'll go on a slow ride. Take our time. We no rush. We covered a bunch of stuff today. We really did. I'm hoping there was stuff that you may have known and, man, I forgot about that. Or a lot of stuff like time complexity on that's in. That's new. That's new. Huge, huge. All right, I'm gonna shut this down, kill the second video.